Bismillahirrahmanirrahim. This video is from chapter number 2 of Mr. Boylestad's book of EDC, 11th edition. And here we'll be solving end chapter question 36, which is about series parallel clippers. Let's see the question. This is the question given. Input wave shape. We have to sketch the current IR. Current through this resistor is IR. And the voltage V0. So this is the output voltage VO. So the technique that we'll follow is we'll take first half of the input signal, for which there will be positive here and negative sign here. Now the only thing we need to establish is that which path is conducting. Now you can see for the positive at the top, this diode will become forward bias because the positive of the battery touching positive of the diode. So this will become forward bias. Whereas positive of the battery is touching negative of the diode, so this will become reverse bias. So we'll simply remove the reverse bias portion, and so our circuit will become like this. Now we replace the diode with the 0.7 volt battery. So the circuit will look like this. Now you can see that the output is the sum of these two, 5.3 plus 0.7, that is 6 volts. You can write it directly. Or if you have any doubt, we can follow the KVL equation. So we'll write KVL equation from here, minus 5.3 minus 0.7 and plus V naught equal to 0. That means V naught is 6 volts. Now how do we plot? The simplest way is that we take the input and we draw a line at 6 volt. Now this is our output from 0 to 6 volt. This will cut or remove from here. So the output wave shape will be there. And similarly for the negative half. Again, negative half. Now negative will be at the top, positive here. This negative is making this diode forward bias and this one reverse bias. So we remove the reverse bias branch. So this is what is left. We replace the silicon diode with the 0.7 volt battery. So this is what is available now. And the output from here, you can easily see that it is 7.3 plus 0.7, that is 8 volt negative, because negative is at the top. Or if you have doubt, again, you can follow exactly same technique. Okay, so negative 8 volt, how do we plot? We take the input, draw a line at 0.8 volt and remove the extra portion. So this is our output for the negative half. So adding the two, we'll get the final output, which will look like this. Now this was the voltage output part of the question, and now we need to find the current. Now for current, we had seen that for the positive half, this is the output that we get here. So what about the remaining portion? This remaining portion will obviously appear across the resistor here. So the voltage here will be from 6 to 10 or from 10 to 6 volt, that will appear across this. And similarly, in case of a negative, we had this output. So from 8 to 10, this voltage will appear across the resistor. So with these two voltages, now we can calculate the current. So for VI, 10 volt, that means this circuit, the VR, that is voltage drop across, is 10 minus 6. So this is 10 minus 6, that is 4 volt. And we know the current is V over R. So 4 volt divided by R is 10 kilo. So current is 0.4 milliampere. And similarly for this half, it was minus 10 minus 8, that is minus 2 volt is the VR. And IR is minus 2 divided by 10 kilo is minus 0.2 milliampere. So these are the two currents. Now how do we plot the current? Again, easiest way is to take help of the input signal. So this was the input signal shown in the dotted line. Now, as we had seen that in one case, the current will flow only in this range, that is between 6 to 10. So this is our, let's say, 6 volt line. So between 6 to 10, this in this range the current will flow, and current will flow or follow the pattern of the voltage. As the voltage is increasing, current will also increase. So this we can draw the current following the same pattern and up to this portion, and the value or maximum value is 0.4 milliampere. And similarly for the negative half, it will flow between negative 8 and 10 on the line. So this is where the current will flow, and it will follow the same shape, and its maximum value will be negative 0.2 milliamp. You can show it separately also. So just separate this current portion. So this is the current plot for this question. I hope you have been able to follow this. Please let me know through your comments. Thank you.